Alrighty, so we're 5A, area under the curve, and what we're going to work through today is we're not learning anything new as such, but I'm going to make a distinction between a definite integral and an area under the curve calculation, okay? They mean the same thing, but they often have different contexts in which they're performed, so we'll talk about that. So we'll get straight into it. Example problems A. Find the area under the curve y equals 3x squared over the interval from 0 to 1. Okay, so what this means is evaluate the definite integral from 0 to 1 of the function 3x squared with regards to x. Okay, area under the curve. Now if we're going to sketch this function in our graphics calculator, 3x squared is a quadratic, something like this, and we're interested in the area from x is 0 to x is 1. Okay, we're going to be calculating that area there. So we can type this into our calculator. We can also do it in graph mode. I can't remember if I've shown you guys that, but it's definitely something I'll show you today if we haven't. So let's evaluate this using the fundamental theorem of calculus. The 3 can come out the front. The integral of x squared is x to the 3 on 3. And we're integrating from 0 to 1. So that gives us 3 times a third, 1. Now I want to compare this with the two contexts that I've mentioned. So the contexts are, one might be evaluate this definite integral, in which case this is the answer for the integral. Another one might be find the area under the curve, 3x squared from 0 to 1. That's the one we're asked to perform. And because it's area, we have units squared. Area is always some unit squared. In this case, it would be grid units under the Cartesian plane squared. Okay, that's our answer to A. Let's have a look at B. Find K in the form C plus ln B, given the area under the curve e to the 2x, over the interval 1 to k is 4e squared. Okay, so the area under the curve of e to the 2x from 1 to k is 4e squared. Alright, so we'll integrate. Integral of e to the 2x is half e to the 2x. Sub in our upper and lower limit. And then we're looking to solve for k by itself. So that means I'm trying to get first this component by itself, and then I can ln both sides. So what we want to do, we want to get rid of these fractions, we want to move that term across, etc. Let's get rid of the fraction immediately by multiplying both sides by 2. That's going to be 8e squared. And now I'm going to plus e squared to both sides. I'm going to get rid of this component. I'm going to come up here. So we'll have e to the 2k equals 8e squared plus e squared. And they're like terms because they're both e and they're both e to the power of 2. Here I've got 8 lots of it. Here I've got 1 lot of it. 8e squared plus 1 lot of e squared gives us 9 lots of e squared. Okay, we will ln both sides. Now over here, this is going to simplify to 2k. Now, if we were solving this previously, one thing we would just write it as k equals half ln of 9e squared. But look how it wants us to present the answer. It wants us to have some constant plus some logarithm. And so I'm looking at that and I'm going, we can split that logarithm. We have ln of a times b. It's equal to ln of a plus ln of b. Right? That's using log laws. We can split that up. If we collect them using the laws of logs, that's what it will collect to, 9 times e squared. And then ln of e squared, that part simplifies to 2. We have plus 2 there. So we've got 2k is ln 9 plus 2. And then we'll divide both sides by 2. And so we'll have k is half of ln 9 plus 1. And a good way to demonstrate that that 1 does not belong to the logarithm is to wrap brackets around the 9. And just one more thing, because with logarithms there are so many ways that we can present the answer, is this half, okay, whenever we have a number out front, that could be a power on the 9, right? So we could have ln of 9 to the half plus 1, and 9 to the half, that means square root of 9, ln of 3 plus 1, okay? That could be a way it's presented. We will accept full marks here, all right? It's ln b plus c. All right, so look, we haven't learnt anything really new there. Here we're not using units squared because what have we done? We've found a value of k where k is the upper limit of the area calculation. So this isn't an area. We haven't found an area here. We've found a number. We've found the value of k exactly. So let's pull out 5a. Let's just do a little bit of that, and I would anticipate after recess doing a bit of 5b as well. So let's pull out 5a, get started on that.